Hello everyone, Don here with an update on what I've been up to for the last couple of weeks. This last 2 weeks, I've been pretty much working on my PTS Flow Bench. I bought these planes off the PTS website and bought all the equipment from Bruce, the guy that sells all this stuff and the plans. So I'd started building this a couple of years ago, but I'm getting to the point where I want to do some work on I want to flow these cylinder heads I bought for the Mustang. So what I've been up to is getting this cabinet finished up here. And what you can see in here is, instead of using 8 different shop vac motors, 8, 10, 12 motors, I decided to custom build my own fan. And there was a book online I found, get some good lighting here, on how to build these centrifugal fans, and had all the math and formulas in there to figure out to get to the CFM flow rating you want, and if you're after any vacuum or pressure rating. So this cabinet is designed to work at your basic 28 inches of water column pressure for flow testing cylinder heads. Most cylinder heads are flowed at 28 inches of water column. And then, because this is a 2-chamber box, there's a chamber back here and a chamber down there, and they're divided in the middle, and then there's a calibrated orifice plate that goes in the center of these boxes. And then these manometers that I got from him, there's 3 manometers in the one box, and one of them reads up to 16 inches of water column, so that would be the differential readings between the upper and lower box here on the inside. And then the other 2, one reads the 28 inches of test pressure, whatever you want to test up to, and then the third one is for a velocity probe, so you can measure the airflow going into or out of the head and see what airspeeds there are at different parts of the port, which will help you diagnose where you got to do your porting, if you need to slow the airspeed down or speed the airspeed up by the way of porting. So, and then this other box on the bottom here is an automatic manual control. And then here I've got a variable frequency drive. All these got to be remounted in this cabinet here, and then I wired it up. This is wired for 220 volts, but it comes in here and I split the power up, use 110 leg, so I can plug in the power for these little boxes. Then I got a 110 outlet here, so I can plug my laptop into it. And then I got a 110 volt AC fan up here to help suck the air in and out of the cabinet. I got a vent inlet down here on the bottom, so it can suck air in and blow it in out here. And then I've got a little access port here for the USB cable to come out that plugs into my laptop that'll sit on top. So, and then what we got here on the control panel, on-off switch, and then this is a potentiometer. It's turned up right now, but when you turn all the way down, turn this on, as you turn this, the motor will start speeding up, and it's all tied in with the variable frequency drive through this control unit. And then once you use this to bring up to your 28 inches of test pressure, after you have your cylinder head on here and your valve opened up, say 50, 100 thousandths, you make the first adjustment with this until you get 28 inches on your screen, and then you can flip this thing into the automatic mode. And then you wait for it to stabilize, hit a button on the laptop, it'll record that reading. Then all you have to do is go over here and adjust the valve open a little more to the next setting, say 200 thousandths. And then it being this in the auto mode, it will automatically speed the fan back up, speed the motors up to maintain that 28 inches, because as soon as you open your valve a little farther, the test pressure is going to drop. So when that drops, this box will see that drop and automatically speed the fan, speed the motor up to maintain that 28 inches across your cylinder head flow, your delta. And the more you move that, the more the fans will speed up. So, and then these 2 switches here, so when you're flowing intake, these 2 are just manual valves that work with the pitot tubes that go into the cabinet. So when you're flowing intakes, you're sucking the air down into the cabinet. When you're flowing exhaust, you're blowing the air out. So you have to reverse those hoses so the manometers will read correctly. So they come up through these positions switches. So when they're pushed in, that's for reading intake. One of them works the differentials, and the other one will work the 28 inches of water column. They'll read backwards. They'll try to read backwards if you don't, and they're not designed to read backwards. So this will reverse them automatically. And then you have to go inside the box from the side, and you can see these plates have a beveled edge. These are called a sharp edge orifice plate. They come right down to a knife edge. So when you're flowing intake this way, the air has to flow through this way. So then when you're flowing exhaust, the air has to come up through this way. It always comes against this. So down inside the cabinet is another one of these. And then through that, there's an access to get in there and with some thumb screws so I can flip that plate over for exhaust. And that takes care of that. So then the other thing is this fan only works in one direction. So I built a selector here. Right now it's in the vacuum mode. There's a 4-inch hole on the other side of this box. You can see the plexiglass in here. See that 4-inch hole on the outlet? That's on the sheet on the back of this plastic assembly. And this little handle hooks to this valve. Now you can see there's a 4-inch hole inside that plastic assembly. So what happens now is air will suck in through the hole on the other side of this fan, blow it out through there, goes into that part, and it goes down and it goes into the bottom chamber. There's a hole right where this thing pivots here, right on this pivot point. There's a 4-inch hole that matches that hole on the other side of this. So the air goes in and it can blow out. So when it's in this mode, the air will just suck in up here around the top, around this, in through here, or blow out through there, sucking through there, and it'll cause the vacuum to suck through the cabinet and so forth. So that's you have to change this direction when you want to do pressure blow through in this section for sucking. And then you reverse these switches. So they're out for exhaust, in for intake. And then these are your speed control to start with. Master switch, auto manual, and then I did have a switch on here for reversing the motor, but that fan setup doesn't work that way. So that's kind of where I'm at. I'm at the point now where I'm almost finished. I went to put the bolts in for the motor, and I've got carriage bolts there, but the problem is when I try to tighten these carriage bolts up, the nuts, nylon locks, they spin. So I just got to go grab me 4 bolts, regular hex head bolts to bolt that motor down. And then I need to either make a tensioner for this, because this will spin clockwise. And this is a harmonic balancer off of a Ford 4.6 liter motor. I didn't want to use a V-belt. For one, these pulleys are really expensive when you get the V-belt. I paid, I don't know, like $30, $35 for this thing on eBay. Super cheap. And then I found an alternator pulley. This is an overspeed pulley for an alternator. So I got that. And then I've got these pillow block bearings that are meant for CNC stuff, but they're good for like 20,000 RPM, the bearings. This is a double bearing, that's a single bearing. But that fan in there is 1.25 inches wide, and the blades on it are curved. There's, I think, 8 blades in that thing. But when that thing spins at 10,000 RPM, this is a 3,450 RPM motor, and this is a little over a 3-to-1 induction. I think this is 1.8 inches. This was just a hair under 7 inches. It's going to be over 10,000 RPM, but at 10,000 RPM, that fan is capable of flowing 600 CFM at 44 inches of water column, because you got to take the 16 inches for the range of the orifice plate for the manometer. You have to add it to the 28 inches of test pressure, which gives you 44 inches of vacuum or pressure that you need to run this system to get 600 CFM. So this thing should be capable, if the math was correct, which it should be, is good for 600 CFM if it works. So that's kind of where I'm at. Like I said, all that's left to do is get this thing bolted down. I'll either have to shim that up, or I would like to put possibly a tensioner on here, because when this thing turns, this side will be the tight side and this will be the loose side, and I can either tension this, you know, it's not bolted in yet, it's just setting in there, but it needs tensioned up, and I'm ready to hook the laptop up to it and give it a test run and see if it works. The motor and all that does work, because I've had that work before. I do have the wires sticking out right here, so I got to wire it up. And that is a 3-phase 5-horse motor. So, but you put 220 volt single phase in, goes through the variable frequency drive, and that simulates a 3-phase output, and it's variable from 0 all the way up to 3450, and you can actually run the motor a little over that rating too. I mean, you might be able to get it up to 35 to 4,000 RPM, but you end up losing torque at that point. But in the math of calculating that fan assembly out, it says it'll take 4.75 horsepower, so that's a 5-horse motor. Okay, now the next thing I done, I mentioned in the last video that I was going to convert this over to a continuous flow carburetor. There'll be no float bowls in there. I modified the needle and seat, took the needle out of it, and I drilled it and tapped it and put a set screw in there to make a restrictor jet in here that I can change out if I need more flow, or if that's too much flow I can take it out. And then the other problem I had was I needed to tap the other hole on these. So what I did is I did find a tap. It's a 7/8 that fits the original holes, and then I had to tap out the other hole on the other side. And what I did is I made me a little jig for that. I made a tapping jig. So that's where this comes into place. This is just some scrap plastic from making that fan box. And what I did is I measured up from the table to the center of this thing, got a measurement, cut this block out, bored a hole through it, 5/8 hole in there, so that it would keep this tap just like this. Slide that tap all the way up in there, like so. See if that helps a little bit. And then what I did is carefully centered the bowl. What I did is put the tap in just like this, and the side that was already threaded, lined it up so it was straight, then I marked and drilled holes into this plastic and tapped them for some 1024 screws. And then you take this screws back out, pull this out, and then I grab the other bowl. This is the front bowl, and this is the normal inlet for the fuel pump or fuel line. So then you take the other bowl, the back bowl, which has this one threaded but not this one, so then I can take the one that wasn't threaded, bolt it onto there, leave the tap in the jig. You got to leave this tap in the jig. It's a nice stubby little tap. Found these on eBay. It was like 25 bucks for the tap and die, and it's a nice quality tap too. If it's made in China, and kids are getting pretty good at making stuff over there. So then you take the bowl, and you can see the 2 bolt patterns for when the bowl's on this way, or when I have to put the bowl on this way. But either way, you slide the bowl up in there, slide the tap up till it touched it, lined it up good, put the screws in, tighten them down, and all I do is put a little oil on there and I clamp this right to the bench here, right to the table here, and then just crank this baby in. And I tell you what, man, that thing just did a perfect job, absolute perfect. And then the other one, you know, then the bowl has to be bolted on this way. So if I was to make this to do like a production run, I would probably make a plug that fit in that hole nice and smooth, and then reduce the shank, reduce it down to 5/8, so then you could slide that right in with that plug. Nah, you couldn't really do it because you can't get the plug out. But it would allow you to kind of center it up to make a real accurate drill point here. Or you could make this kind of removable or something. But it's anyway, I only had to do 2, and I did both, and they came out perfect. Because if these holes aren't straight, when you put the fitting in there, it's not going to seal on this lip. So it had to be very close. And then it may not still, I mean, until I get the fittings put in there, I'll put some dye or something on there, run it down so it touches, take it out and see how flat that is. It may require a little touch up, or a gasket, type of gasket that can crush a little bit to seal it if it's not accurate. But they're both done. Both sides are clean. Now, let's see, this is the original inlet. So the fuel comes in here, comes down through there. And then when the fuel level comes up to this level here, I'm going to have a hole drilled right here on this side. And then the plugs I'm buying to put in here, I'm going to drill it and tap it for probably like 1/8 or 1/4 inch NPT threads. Put a fitting on there, so when the fuel comes up, it runs through that hole, drains right back out of here, and goes to a little pump, pushes it back to the tank, or adds it right to the return line of the fuel system. So, and then if for some reason this thing doesn't work out, all I gotta do is take these out, put the needle and seat back in, put the float back in, and just plug this hole. The hole you drilled in here, it'll just get fuel in there, it'll settle and lay in there, but you can still use it as a standard normal carburetor if this doesn't work out. So that's kind of where I've been at. I just did this today, this piece, and I've been working on this for the last 2 weeks, and I've also had a issue. I have a Yamaha rack stereo system I bought when I was in the service back in the mid-80s in Japan, and a couple of the components have started acting up, so I had to take them into a local TV repair shop and got the guy to fix that stuff up for me. So I've been spending a lot of time tracking down schematics and getting this stuff for the guy to help it make it easier for him to do. But got everything back, it's working good. Now I'm replacing the woofers in my speakers because the cones and stuff are dry rotting on them and they need replaced, so I'm just putting new speakers in it. So that's kind of where I'm at now. Didn't really do anything with the car, even though I do have the T-top frame ready to go in. That's all painted, sitting up there on top of the thing waiting to go in. But I've just been going a different direction lately, just bouncing around from project to project. The blast cabinet's working great, been cleaning up parts with that. All these carburetor parts, as you can see, they've all been cleaned up with that. Oh, and here's my regulator. I dug out the regulator and even blasted this piece. I took that off, took it apart and blasted it, took all the fittings out. And I took out the spring because this was on a fuel injection car, and I recut and I measured up that hole in here, and I was able to figure out I got to run this, around 9 or 10 psi, so I had to change the weight of the spring in here. I was actually able to find it at a local hardware store about the right size that should work. So all I need to do now is hook up some airline or something to it and pressurize it and adjust this and put a gauge on it and see if it'll set down to my 10 psi. But it should be able to go lower than that and be able to go higher than that, and it'll be boost boost sensitive. So when boost hits it, it'll increase pressure pound for pound. Like I said, you've already seen this all ready to go. All you do is put the gear back on it, put the clips back on this, and put that on there, and that's ready. Get a new cap for it, and then I got this vacuum advanced modules getting modified to be boost referenced also, so it's be a mechanical boost reference. All right, I haven't done any more with this. I do have the drawings finalized. I just want to cut them out again out of some little thin board like I did last time, just to verify the fit. And then if that's good to go, I can get those plates burned out from a local place that does water jet. So I get them to do that. So this thing is pretty nice, and it's going to be quite different. That plexi, it's not plexiglass on there, that's Lexan, so it's plenty tough. That fan is, like I said, 1.25 inches wide, 10 inches in diameter at maximum RPM. To get the 600 CFM, it would have to spin 10,000 RPM. And with this belt set up on here now, it'll do more than that at 100% speed. So, okay, I think that's, well, I had to take and replace a rear wheel bearing on my car. Every time I step on the brakes, as you got real slow, you kept hearing this little grinding noise, like grind, 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 and it's like bad brakes. So I pulled the brakes all apart, could not find anything wrong with the brakes. So I finally determined it had to be this bearing. See if I can get some light in there. But inside that bearing, there is little tick marks. Right there, I can see them. See them right there about the 9, 10, 11 o'clock. There's 3 marks in that bearing seat. Right there, I can see them. There's one there, one there, and one there, and there's a real faint one here. Those little buggers, when you applied the brakes, it must have put a little load on the side of the brake rotor that it was making them thing. Every time they came around towards the top or wherever the brake caliper is, it'd go sound just like a rusty brake rotor. But nope, it was that damn little ball bearing. Well, I tore this apart just to find the damage, and I found it. I'm really surprised, but brand new one of those off eBay was 35 bucks to the door. You can't beat them Chinese kids. All right, I think that's going to do her. I just kind of cleaned up a little bit of my mess I've been making in here. I'm going to get back on to the next phase of the Mustang is to probably start running the brake lines, get the fuel lines run. I did make a tubing straightener for I think it fits the fuel lines. I got stainless steel coil lines for everything. So I'm going to run the lines differently. I'm going to use an in-tank late model fuel injection fuel pump, just a stock one. The 88 liters would be more than enough to feed this motor at, at 10 psi when it's rated for 40 psi in the car. So the bottom of this car is pretty much done. All it's left to do is, like I say, run the brake lines, run the fuel lines, and finished figuring up the exhaust system. I still needed to go from the turbos into the catalytic converters, and then the catalytic converters into the X-pipe, and then so forth. But from the X-pipe back, it was done. They're just tacked together, and I haven't welded anything yet until I'm happy with the fit and finish. So, let's see. But yeah, the whole idea is getting that bench done so I can flow test these stock form before I get in there and start polishing and smoothing things out, and then see what I can do with them. So, all right, folks, I'm going to go ahead and cut her off there for this week. But that's kind of what I've been up to. Just a little mix of everything this past 2 weeks, I guess it's been since I had my last video. So I'll work on this tomorrow, try to get that finished up. All these components got to be mounted yet, so they're not vibrating. They got to be mounted horizontally in there and put the door back on. I do still need to finish trimming the doors up here on the edges, so when you open them, it'll be trimmed out. I still have material this left to finish the trimming. So, okay. I didn't really do any more cleaning. Those are some parts that have been cleaned already from the cabinet, but the cabinet's still working great. Absolutely love it now. That's going to be my cylinder head kit. The tube there, of course, is going to be in the middle. I'll bore that out. Those little blocks. It's going to be set up for a 3-inch bore or stroke, because that's what mine is, with a 4-inch 30-over hole for the pipe. If I ever do anything bigger than that, then I'd have to make a new jig for flowing someone else's heads. You can always stick them right on the bench too, but it's always nice to have the cylinder on there to represent the cylinder. Okay, that's going to cut her. We'll cut her off there, folks, and as always, feel free to leave any comments, questions, or concerns. Sorry about taking so long with the videos, but it's life. You know, I do this just so people can see what you can do and how I do things. So, as always, feel free to leave the comments, questions, concerns. I'll answer them as they come through, and try to get this video about once I get this thing up and running, and give you guys a demonstration of how it works. So, all right, until next one, folks. I guess that's going to do it for today. Again, thanks for watching my videos and taking your time to do that. So, all right, I'm going to cut her off now. So maybe I'll see you guys again next week. So for now, this is Dino Done Out.